Hey guys, welcome back to the channel. This will be part two on the 2009 Mini Cooper from Emilio Zaror. He approved the repairs, so as you can see, I'm already even sealed the computer, and I have it a little lefty because silicone is still drying up. But all right, so nothing is on. I actually even have to turn my power supply on because I always like to do the tests, if possible, with the computer completely assembly, just to make sure that there is nothing shorting and everything. Even though I use a special thermal paste that is not conductive, I want to make sure that indeed nothing has changed and the computer has plenty of communication when it is completely sealed up. All right, so that should be on. I can turn this on, and that is a good sign. We have the 5.0 reference, healthy draw, which includes what this box is drawing, and also the BCI for the Phoenix Max. So that is perfect, no problem in there. Let's make sure this is on, and it is. Let me establish communication as we saw before. We don't need to see the actual picoscope, but it is there, and we have now the communication. One thing that I like to see now is that we don't no longer have the 3.4 volts, remember, that we had before. And the reason we don't have is now because the computer is repaired. So I re-established the communication properly from the ground on the sensor and the signal through a resistor. And this will be acting as your coolant temperature sensor. And now we have a difference. So that is great because it means everything is good. I am very confident that that is the case. The voltage has dropped down to 2.2 volts, 2.02 volts, and that is based on 1400 ohms of resistor that I'm using with my decade backs. All right, so it looks like a ID, no problem. And I can see the communication. Again, it's only one module. Remember, what the scanner is trying to do is communicate with a gateway because this is not the normal communication. But since it can read the bin and knows the car is the engine computer is there, so it's not rejecting the communication, but it's still trying to, is anyone else there? Is anyone else there? And you can see that in there. You see, trying to see if it's somebody else that responds, and that's why this first step in here is taking a little longer. If I would have to, or if I would have established the manually select the vehicle and I'm going to manually select, it would have been a lot faster. But I always like to do this so we can read the bin. And this is an R55, so we know that we can select that. And we're going to select drive, ECM, which stands for engine control module, but this is DME, right? So this is the way Mini Coopers and BMW name their computers, which is digital motor electronics. I'm just going to go a little briefly here. We can see still the same values, last programming date of July 2011, so it's not up to the latest and greatest, but it's working good, and I'm not changing that because that only can be done in the vehicle. We are going to clear the fault codes because I have not done that. This is the first time I connected to the computer after the repairs. All right, so fault codes are clear, and we do have, I mean, we're going to have a lot of fault codes, but the one I'm looking for to not have is to F2F1A because I have the coolant sensor connected, and we don't, which is great. So that is already a hint that we are in the right path. We are going to read the data stream, and as I did before, I will select temperature values, and I'm only going to select the engine temperature and the DME inside temperature because that's all I really care now. Okay, we now immediately see a difference. So for those that haven't seen the first part, when the computer was having a problem, the actual ground side of the circuit, it was damaged due to corrosion on the computer. And I'm going to show you the pictures. I'm probably going to add it here. So you will be seeing the picture on the left side where it was really corroded. And then after, when I cleaned the connectors and now repair the computer. When the computer wasn't working properly, this voltage or not voltage, Fahrenheit degrees was always in 68. The reason that happens is because internally the computer has a resistor to compare and add the value of the resistor on the actual sensor. And that resistance is going to change. Obviously, it's a thermistor, right? So when that resistor changes due to temperature on the engine, right, the resistance is going to change, and the computer is going to know that the value, the sum of those resistance equals the voltage, or sorry, the temperature. What the computer will end up seeing and is only seeing is voltage. So what the computer does, knowing the voltage, which is going through a voltage regulator, and I can read the voltage, and knowing the value of that resistor internally in the computer, it knows what the resistance of the sensor is, and then it calculates and tells us the temperature. That's how the mathematics inside the computer gets done. But yeah, so what I want to do now is I'm going to select just the computer temperature, the engine temperature, sorry, and I'm going to change in here this value. So I'm going to go over to very high, so that's going to drop the temperature, and we can see that we're now going into the minus. I'm going now to, because I was at 91,000 ohms, I'm going to come back to that 1400, and we can see the change immediately happen in the computer. I'm going to actually go uh, to 400 ohms, and that's going to go into overheating pretty much because we're now in 197. So actually, that's actually operating temperature. So 199 degrees around what these engines work, and we can see that. And I'm going to show you here. Let me move this cable so we no longer have that. So I'm going to put the one. Sorry, not down, the one, and we will go down to 138 degrees or 132 degrees, sorry. And if I put now the 91,000, that's where the value drops completely to a negative degree, which probably will never happen on the car due to the circuit design, but we can definitely see that the computer is indeed normal in its reading temperature with a sensor. Because right now we have, or I have, a green wire connected to the ground of the sensor, and then a yellow, or in green in here and black, but then transferred to the leads that I'm using in here. So green and yellow, and those are the two wires in here. The next thing you see here is just my green shallow from the oscilloscope, and that's how we can see the voltages. If I change the time base to faster, or actually it's a slower um, reading, like let's say 50 or so, we can see first more of the communication happening on the computer. But when I change the resistance, I'm also changing the voltage. You see right now I went from that 2 volts or whatever it was to that upper voltage, and we can see immediately the drop, and that's what the resistance at the end is doing. It's changing the voltage. The computer calculates knowing the voltage that is coming through, divided into the known resistor inside, and knows the resistors on the sensor. And that's how, again, how it works. But yeah, okay, Emilio, your computer is working 100%. We have a very healthy communication, a 5-volt reference, and now a fully working um, temperature sensor circuitry inside the computer. He has a brand new coolant temperature sensor and thermostat on the car, and he's actually spoke to me. He's going to clean that connector. He's going to take my recommendations about using dioxide. For those that have not seen or will not see the first video, this is the fluid that I am talking about. This dioxide D5 is really good. All you do is apply it into the connector, let it sit for an hour, 30 minutes or so. Scrub it with like a toothbrush or a brush like this. This is uh, horse hair, so it's a little stronger, and then you can get more inside if you have a kit like the ASWay kit, or you have those diamond um, connector cleaners, which let me actually look for online. Give me one second, guys. All right, this is just an example, but yeah, so these are diamond tip uh, terminal cleaners. So these are specifically for that. The reason they are like that is because you can grab a terminal when it's a mill, and you can file back and forth to clean any corrosion or so. You will also have, if I like all the search that I did was for terminal cleaner kit, you will also have more of those like this one. These are round, but yes, you have. Let's close this. So we can see more in here and how that works. Again, it's a file. This will be for the female side that you can enter and clean the terminals. Again, use the dioxide and everything will work really, really good. Be careful not to force. So make sure that you are actually smaller than what the terminal cavity is, like that you can move around without spreading the terminal and at the end creating more problems. But yeah, so everything is good to go. I can show, or I will probably say, to not make this video too long, please visit the first part. I'm putting the link in the description of this video, and I show all the wire, how to do the wire integrity on these thermistors or a three-wire sensor. I explain a lot of that, how to use B&W ISTA for getting all the information and wire diagrams that you need. Anyone can access it. It's a $30 a day subscription. If you don't, if you're not a shop or a technician, then yeah, just buy it one day and then you will have the access to everything. You can download PDF, take pictures, anything you need. And at the end, if you need another day, I mean, pay another $30 and you got all the information in your hand. All right, guys, thank you so much for visiting the channel. Emilio, thank you so much for sending your computer. I'm so happy that I was able to repair it because my hopes were not too high at the beginning, but then it actually eventually came out really good. The computer is looking like brand new, and so are the connectors. All right, guys, thank you so much. Don't forget to subscribe. Bye bye.